Hi there, and welcome to this lesson on Further Pure Mathematics 2. And in this lesson, we're looking at loci and regions on an Argand diagram. Now, in previous lessons, we've looked at equations and loci. And equations always give you a line that you need to draw. Now, just as with normal inequalities, if you have inequalities and loci, then what you'll get is a region that you have to shade, where the whole of that region is represented by the locus of a point. We'll go straight to a series of examples. So example 1, on 3 separate diagrams, shading the regions represented by these 3 inequalities. I'll let you have a go yourself first, so pause the video and then come back to me again when you're ready. Okay, let's have a look at these. So the first one, the modulus of z minus 5 minus 2i is less than or equal to 2. Now, what you would do first of all is just draw the locus of the equation. The modulus of z minus 5 minus 2i equals 2. And that'll give you a circle which has center 5, 2 and radius 2. So that would be the loci if this was an equation. Now, we have an inequality. We're being told that the distance of z from this point has to be less than or equal to 2. That means we could be anywhere inside this circle, including on the perimeter itself, because equals 2 has been allowed. So that inequality represents the inside of the circle, including the circumference, and it would give you that. The second one, the modulus of z minus 5 is less than the modulus of z minus 7. Now again, first of all, just draw what you would have if it was an equation. The modulus of z minus 5 equals the modulus of z minus 7. And that is the perpendicular bisector of the line joining 5, 0 and 7, 0, which is that line here, with the line x equals 6. Then worry about what the inequality says. And the inequality says that the distance of the point from 5 has to be less than the distance of the point from 7. Well, that'll be the whole region to the left-hand side of the line. But it can't equal the line because it doesn't say less than or equal to z minus 7. It does have to be strictly less than. And as with normal inequalities and regions, what that means is that this line will need to be a dotted line to show that it can't include the line itself. So the region is all of this yellow region, and this green line here has become a dotted line because you can't actually be on the line. Third one, the argument of z minus 3 minus 2i has to be between 0 and pi by 4. Again, what I would do first of all is just draw the equation. When is the argument equal to pi by 4? Well, that represents the half line that starts at 3, 2, doesn't include 3, 2, and makes an angle of pi by 4 with the positive x direction. So if it was an equal sign, that would be the locus, the line going diagonally upwards from the point 3, 2 at an angle of pi by 4 with the positive x direction. Now, what we have is that z, or the argument of that, has to be more than or equal to 0, but less than or equal to pi by 4. That means you can be anywhere in this region here, where it's bigger than 0 on the positive x direction, but less than pi by 4, or equal to it. In both cases, we have equal to being allowed, so both of these lines are solid lines, because you can actually be on them. Okay, example 2, exactly the same 3 inequalities, but this question is asking what would happen if all 3 had to be satisfied at the same time. So it's the same 3 inequalities. Have a go at doing this yourself, then come back to me when you're ready. Okay, so all 3 things have to be true. You'll get something like that. The first one says you've got to be inside the circle. The second one says you've got to be on the left-hand side of this green dotted line at x equals 6. And the third one says you've got to be between this line here, positive x direction coming from 3, 2, and the line here at pi by 4 going from 3, 2. And the yellow region is the region that satisfies all three inequalities. Okay, if you've got the textbook, then turn to page 64 and have a go at exercise 4C. Thank you very much for listening, and cheerio.